everyone. Thanks for joining. Hope that everyone's now okay after lunch, and let's get some fun stuff after the heavy lunch. And today I'd like to talk to you about distributed tracing and how you can implement it in your app using the OpenTelemetry open source project. But first, following all the Star Wars cues that we saw in the keynotes and being on the week of May the 4th, and since I'm a Star Wars geek and an open source geek, I'd like to greet you all. May the open source be with you. And actually, that's from last year's DevOps UK, around the same time of year. So I came with the same shirt. And thanks, Sharat. I don't know if he's here at the audience for making the tweet about that. So my name is DOTAN Horovits. I'm the principal developer advocate at logs.io. Logs.io provides a cloud-native observability platform that's built on popular open source tools such as OpenTelemetry and Jaeger that I'm going to mention today, and also Prometheus and OpenSearch and others, and provides them as a managed platform built for scale. I'm also a CNCF ambassador. CNCF is the Cloud Native Computing Foundation, the open source foundation under which there's Kubernetes and OpenTelemetry and Jaeger and Prometheus and probably many other projects that you know and use. So if you have any question about the CNCF, feel free to grab me after the talk. Happy to talk about any of these. I also have a podcast called Open Observability Talks about DevOps, open source, observability, platform engineering, and the like. So if you're into these topics, do check it out on your favorite podcast app or on YouTube. And as you can see, you can find me everywhere at Horovits. So if you want to reach out afterwards, happy to connect. And if you have questions, or if you're tweeting or tooting or posting anything interesting out of this talk, feel free to tag me. And let's talk about tracing. How many people here use tracing with a show of hands? Okay, and amongst those, how many use tracing today in the systems? Okay, not many. So good thing I prepared these slides, basic slides about why we even need distributed tracing and what's it for. So, and it's a valid question because until not so long ago, we didn't have that. And we managed just fine with logs and metrics, and the reason it worked so nicely with the classic three-tier applications, or what today people call the monolithic apps, is that it worked nicely. The metrics used to alert that something happened in our system, and then we could root cause the system or the issue based on what did we used to do. We used to look at stack traces, we used to look at logs, we used to maybe step through the code with a debugger, right? That's what we used to do. But now that we have maybe hundreds of services traversed to satisfy a single request in a microservice architecture, if now suddenly the request breaks and something doesn't work, or suddenly there's a very high latency or performance issue, how do we root cause that? And the problem is that many of the methods we used to use in the past are very difficult to implement in this case. So if you want to debug through the code, so taking all the microservice architecture, not just my service, and running it locally, not always feasible. And even if feasible, very low odds that the same issue, let's say the performance issue or whatnot, would be reproducible on the local machine, right? And let's talk about stack traces or log lines. Then how do we find when we have hundreds or thousands of services, and each service may be serving hundreds or thousands of requests per second, how do we find these specific log entries that map to the request with the problem? And more than that, how do we tailor these different log entries from different services to get the full sequence according to causality that is essentially the full request? So these are the challenges, and obviously, as the complexity grows, it's becoming practically impossible to implement these these cases and to track the execution flow. And this, by the way, is taken from just a subset of Uber's microservice architecture, already, I think, over a decade ago. So probably by now it's even more complex. And just think of this pink distributed transaction trying to traverse it through this monster. So that's what distributed tracing comes to solve. And I took the definition of open tracing, but it doesn't really matter. The important thing about distributed tracing, as you can see, it's a method to profile and monitor microservices architecture. And the important part, I put it in bold here, that it helps us pinpoint where failures occur and what causes poor performance. That's the essence of what we want to get out of distributed tracing. The forefather of modern distributed tracing is Google, essentially, that created DAPA, their internal tool that they created to manage their massive distributed system over 2 decades ago. It wasn't open source, but they then published a research paper that you can see here on the screen back in 2010, which influenced essentially all modern tracing tools that you see out there today. So very influential paper. Actually, I had a fascinating episode on my podcast on Open Observability Talks with Ben Ziegelman, who was part of the Google team behind DAPA. So if you are interested to hear more about that and also about the metric side, that is less the topic of today, do check out this episode. Fascinating insights that he provided from Google's experience. So let's go back to tracing. So what's the essence of what we get out of that? You can see here the main bullets. First, we can understand the service dependency. So seeing this sort of a map like you saw from Uber or what you see here illustration, just see which services depend on which. And the beauty is that we don't need to maintain documents that quickly become irrelevant and outdated because people don't bother documenting and updating documents. This is a live representation derived by the interactions in your system in production. So you have an always valid system architecture based on what actually is deployed in production in your environment. You also get an understanding of the request latency sources. If I have a long-running request, why and where is it coming from? And to identify the critical path in our performance, where my system spends most of its time, and if I want to improve, where should I focus most of my efforts, where the critical path is, and also to understand the request context. So we'll see many of these today on the talk. And now that we understand what distributed tracing is, I would like to go over some fundamental terms and basic concepts so that we have the common language to then talk about how to implement it. And obviously, the first and foremost term is the trace itself, which is the record of activity throughout of your request throughout the distributed system. That's the request. You can see here the trace. You can see here on the left-hand side the visual representation as a directed graph where a user calls service A, then calls service B, then calls service C and D, and then calls service E. Each one of which is a span. I'll say a word about the span in a second. And the trace is typically visualized in what you see on the right-hand side as a Gantt chart or as a timeline view, which makes it very easy to understand how much time was spent on each operation on the flow, and which operations ran in parallel, which ran sequentially, and the time sequence of the execution in general. So the spans A, B, C, D are essentially they represent a single operation within the flow, and they're represented by the operation name, by the start time, by the duration. That's the basic information, but also additional context. It could be attributes, tags, events, and any additional context that you may have. And the nice thing is that, I'll say a word about context in a second, but one thing that's important that people keep on asking, so what is a span? What could a span encompass? And the nice thing is that it can encompass in general anything you'd like. It could be a single line, all the way, I don't know, addition of two numbers, all the way down to very complex logic, algorithms, RPC calls that fan out to downstream systems. It's really up to you what's the granularity of a span. So that's a span, and the first one, by the way, A, is what's called a root span, the one that the endpoint was invoked that started the request. And now a word about the context. This is something that is very important, and I'll emphasize it probably a few times during this talk, because it's somewhat different than other telemetry that you may know, like logs and metrics. The concept of a context, because the context is a set of data, essentially, that is required to move the trace information across boundaries, across and encompass the relationship between the different elements of the trace. So obviously you have the unique identifier that's called the trace ID, the global unique identifier. You have other identifiers that are in the context, and as I mentioned before, the context is flexible enough to actually capture many, many other things. So you want to capture the URL of an HTTP call. It could be part of a context. You can capture a SQL statement of a database query. That's another type. So it's really up to you what kinds of context you would like to, custom context you may want to grab from your application. And it depends on the instrumentation, which is the main part of our talk today. So we'll see how it's done. Another very important concept in this regard is context propagation, which is how the context is bundled and transferred across boundaries, across the service boundaries, thread, process, service. And this is very important because although it happens usually underneath the hood for you, thanks to the SDKs, to the client libraries, it is something that you need to be aware of, because many times, and I'll talk about it a bit later, people run into broken context that then they don't have the nice sequence in place. So keep it in mind, and we'll get back to that. The way that it's propagated in practice is typically over HTTP headers. There's a W3C spec specification that details all of that. But again, you don't need to be bothered by that, because typically the client libraries will do that for you. The last thing that I want to say, and the topic, by the way, will be the instrumentation. So I'll elaborate more, but instrumentation is essentially the way that our application generates and emits those spans for each operation invocation. The last point that I want to make, that I won't have time on this talk, but very important for you to be aware, is sampling. Tracing could be very intense in terms of storage, and therefore, when it's POC, it's fine. You can sample all of them, but in production, usually you don't collect all of them. You take only a sample of that, and the sampling is something that you can configure on the client libraries based on policies. You have sampling policies, like it could be constant, it could be probabilistic, it could be rate limiting, different types of policies that you can configure. There are strategies like head-based and tail-based. It's a whole different lecture that I have on that. Just keep in mind, if you start with that, it's fine, 100%, but keep in mind that once you transition to staging and to production, you'll have to think about how you want to sample your data. And let's have a look at the way that it looks on the system view. As you can see, you have the services. It could be a polyglot also. It doesn't have to be strictly Java or a single language. Each one, for each operation, generates and emits a span for each operation, just like you emit logs, traces from your application. And then, and you have an example span here, like a service front-end, operation HTTP get/dispatch, start time, duration. That's the way that you can visualize in your heads what a span is. Then it's sent to a collector or an agent that collects all these spans, reconstructs a trace from these spans based on causality, and then sends it to a backend that then you can analyze and visualize, for example, this timeline view, this Gantt chart that we talked about before. Now, being a CNCF ambassador and an open source enthusiast, the popular open source stack for that is to use OpenTelemetry for the client-side instrumentation, the APIs and SDKs and client libraries. Then OpenTelemetry also has a collector piece. I'll talk about that in a minute. And Jaeger, which is another project under the CNCF for the backend analytics. Okay, so that's the recommended stack in the open source sphere. And now that we understand distributed tracing, how it works, I would like to zoom in to the topic of today, which is what you saw before on the left-hand side, these circles on your application, the instrumentation. Let's zoom into these circles on the left-hand side. So let's talk about instrumentation with OpenTelemetry. But first, who knows about OpenTelemetry? Who is familiar with the project, with a show of hands? OK, we have a few. And who uses OpenTelemetry today in his system somewhere? Not just for tracing, for anything. OK, nice to see. But I see many are not familiar, so I want to give a brief overview of OpenTelemetry. OpenTelemetry is a framework for generating and capturing telemetry data from your application across traces, but also metrics, logs, and actually recently we also added continuous profiling, a fourth signal. So although the topic of this conversation is tracing, keep in mind that this is a unified framework, actually one framework to rule them all, if you like, for observability. It started as a merge of open tracing and open sensors, for those who are familiar with these or still use them. By the way, it's also not tied to Jaeger. I showed before the OpenStack recommended open source stack, but it doesn't have to work just with Jaeger. It works with many others. I will show that in a minute. It's, as I mentioned, an open source project under the CNCF, the Cloud Native Computing Foundation. It reached GA, general availability, already 3 years ago in 2021. So it's pretty mature, stable, and battle-proven for testing. For tracing, sorry. And if you want more information about OpenTelemetry, you have the QR code there on the top with a beginner's guide to OpenTelemetry, where you have a lot of information about the project. But just to go over the main components of OpenTelemetry. So OpenTelemetry has, let's start with the, before we go to the components, OpenTelemetry has a unified specification that is language agnostic, and it's, of course, vendor or tool agnostic, that defines the API spec, the SDK spec, and the data spec across all the implementations. So that's a conceptual thing to keep in mind. And then you have the client libraries, the APIs, SDKs, the auto-instrumentation agents. On the application side, this rectangle on the left-hand side. This will be the main topic of today. That's one set of components. Then there's the OpenTelemetry collector component, a separate component that essentially can collect all the application tracing metrics logs from these SDKs and client libraries, but also from infrastructure components, such as Kubernetes, Docker, Kafka, Jenkins, Jira, whatnot. It has a set of a wide variety of receivers in many protocols to get from many sources. Then it has processors that can do a variety of jobs, like the trace sampling that I talked about before, but also filtering, batching, and many other things. And you can also concatenate, like chain them together to get more elaborate logic. And then it has exporters in many protocols to send it to your backend of choice. It could be Jaeger in one example that we'll talk about today, but it can also be other open source tools, like for Prometheus to send metrics. You can use Prometheus Remote Write Exporter. You can send it to Logs.io. My company has an exporter, and many other vendors and tools out there. So really flexible to work with whichever backend you have. And maybe one word about another important piece is OpenTelemetry also has a protocol called OTLP, a general purpose, vendor agnostic protocol for transmitting telemetry data, essentially. So that's OpenTelemetry in a nutshell. Again, you have the QR code. There are lots more information about each and every one of those. And today we'll focus about the left-hand side with the application's instrumentation. So let's zoom in on instrumentation. which, as I mentioned, is essentially making our application emit traces or other telemetry. And just to think, it's a big word, but behind it, if you've added a log to your system, that's instrumentation in a nutshell. And there are essentially two approaches to instrumentation: manual instrumentation and automatic instrumentation. And many people get confused about that, so I want to make sure that at least this part gets a takeaway that you can take with you about that one. Manual, of course, as the name suggests, means that I code against a set of API interfaces, and I have an SDK that implements the API to generate and emit, in our case, spans. So when I add a log statement with, I don't know, log4j or your favorite framework, I essentially instrument manually using the log4j API and SDK. So that's manual, and automatic instrumentation is the other approach, requiring little to no coding at all to collect this telemetry from our application, and of course no recompilation of our code, which is very important as well. And typically it's done by attaching an auto-instrumentation agent, as we'll see in this case. Of course, it's much easier, no code changes, no recompilation, and it captures common cases like inbound request or outbound HTTP calls, as you'd normally expect. But on the other hand, it's of course less flexible than the manual instrumentation, where we need to code, we need to put some lines within our code to do it, but then we have the full flexibility to determine what exactly are the scope of the spans that we generate and emit out of our code, and which context we collect from our application. So that's the flexibility that we get with manual instrumentation. And let's look and see how each one works. One note is that the purpose is not to, I'll show snippets of codes and things like that. The purpose is not to go line by line of all the coding options and all the combinations of configurations, but rather to give you a sense of how these are done, so that you know what you're getting into, and to evaluate what best suits you and your systems and your project. And I will share a how-to guide that you can actually follow with snippets, so don't worry, you have that. And by the way, also on Friday, there's here on the conference, there's a workshop for OpenTelemetry, hands-on workshop with a dear friend, Matthias. So if you do want to try out hands-on, I think he chose Java and Python, so you'll have some Java piece to play with as hands-on Friday if you are interested in that. So check it out on the schedule. So let's start with auto-instrumentation. As I mentioned, auto-instrumentation requires little to no code changes, we'll see, no recompilation, and the method uses intelligent agent that is attached to the running application and extracts trace data for you. And to be honest, OpenTelemetry works with many languages, okay, and supports many languages, but maybe I'm biased, but I think Java is maybe the most advanced in OpenTelemetry, especially in the auto-instrumentation agent. Really, really powerful. So, so the Java community made a great work there with OpenTelemetry. So here's how it's done. Very simply, minus Java agent, you give the path to the jar. The agent jar can be attached to any Java 8 or above application, and it captures common use cases such as inbound request, outbound HTTP calls, database calls, and so on, capturing request, response, servlet requests, consumer messages when you have the messaging frameworks, and so on. And the nice thing, it dynamically injects bytecode to capture telemetry from many popular libraries and frameworks. I gave a few examples here on the list. It's just a partial list, so don't take it, go to the documentation, but just to give you a sense of how many you see, obviously, on the messaging. I gave a few examples like Kafka and RabbitMQ and RocketMQ and so on. And the messaging, we see here databasing related, like Cassandra, Couchbase, Elasticsearch, MongoDB, the Hibernate framework, and so on. Also beyond the plain Java, for those who use Akka, Scala, Kotlin, and so on, there's also support there. Cloud vendors, have support even built-in resource providers, Jetty, Jersey, Spring Boot, JBoss, Tomcat, and many, many more. So really, really powerful. And also the agent is highly configurable. So you can configure the OTel. OTel, by the way, is a short for OpenTelemetry. Sorry if I'm saying OTel. That's how we call it in the project. OpenTelemetry resource and service name, batch span processor to batch the emission of spans, sampler, sample rate, rate limiting, and so on. So really, really powerful. And really, the auto instrumentation agent is excellent starting point for most users. Okay, and many found the out-of-the-box instrumentation is completely sufficient and no more needs to be done. So it's a good starting point. But what if we wish to create spans for some custom code? Do we need to skip the agent, the auto instrumentation agent altogether and move into the manual, fully manual that I will show on the second part? And the answer is no, luckily enough. And this is where the advanced automatic instrumentation comes into place with annotations. You can see that you can essentially annotate with a Java agent to create spans around methods of your choice with the @with span annotation. Just need to add a dependency on what's the name, OpenTelemetry instrumentation annotation or something like that. You have that supported in Maven, Gradle, all of these. And use the @with span, and if you want to add attributes, you annotate with @span attribute, and you can add also attributes to the span. So keep in mind, advanced auto instrumentation. This is why I said little to no code. This is the little part that you want a bit more advanced. You'll do a bit of coding, and you get this added value. So that's the auto instrumentation side. Now, let's talk about manual instrumentation, where we need to do some more work, but we get more flexibility. So as I mentioned, OTel provides an API and an SDK for Java, and similarly for other languages. And the API provides a set of interfaces, and then the SDK is the implementation. I'll show you that. I'm not going, again, line by line, so I'll just give you the sense of it. But one note, this is for the end users. If you do need instrumentation for your own library, for your own users, so if you're a library writer and you want it for your users, there's some subtle differences, so follow the documentation for that. So first of all, we need to use the favorite, you have the favorite package manager, Maven, Gradle, you have all the dependencies that you need to add for that. And then let's talk about the simple case of two services, A calling B over a REST call, over HTTP. And let's see how it's done. So the first part, we need to create a tracer, and then using the span builder to create a new span, our root span for service A. And as I said, the context is very important in tracing. The context propagation, and we'll see how to do that. So essentially, we need the service A to inject context, and then carried over the HTTP with a REST call, and then to extract that on the other side by service B. So the way to do that, we use the OpenTelemetry propagator interface to perform the context propagation. And to inject the context into the request header in service A, we use the inject. First we create a text map setter, and we invoke the inject method on the other side with the setter. That's service A, and then service B uses the text map getter to extract the method with it. So essentially, text map setter and inject on service A, and text map getter and extract on service B. And then when we have the context on service B, we can create the span with that context already part of the span builder creation. So we have the context built in. Now that we have that root span on service B, we can also create a child span associated with a parent span. This is done by the set parent while we do the span builder invocation. And now we have the relationship parent-child. And now once we create the span, we can go ahead and add attributes, add events, and most importantly, to end the span when the piece of logic that you want to measure ends. So that's how we capture custom spans, start, end, and that's the flexibility we have with manual instrumentation, and also the flexibility to capture whichever context we have. You have some variable there that measures the amount of, I don't know, a thread pool that you manage, or users, or accounts, or I don't know what. Everything could be part of the context of the span in manual instrumentation. And voila, once you have it done, you have visualization. Service A, that's the long bar at the top, under which you see it ran a bit, and then after a few milliseconds, it invoked service B, and service B ended, going back to service A and done. You can also see that you have a lot of context like tags, logs, etc. So this is for more realistic applications. And let's summarize. So investigating microservice architectures isn't trivial, and distributed tracing is the tool for the job to help us understand the service dependencies, request latency, critical path, and so on. You can use OpenTelemetry to instrument your application. Choose the instrumentation strategy and trade-offs based on what is relevant for you, simplicity versus flexibility, automatic, manual, and anything in between, as we talked about. Check out for your frameworks that you work with what is supported out of the box with the auto-instrumentation agent, and so on. And as I mentioned, Java is very, very elaborate in its capabilities in OpenTelemetry. You have this guide to check out, also how to specifically for Java. So click the Java button, you'll get a hello world to set up with a Java application, so you can follow that. And with the slides that I will share, you will have some more resources that you can use, like the OTel official docs, the GitHub main page, a demo app, and so on and so forth. So with that, I want to thank you very much for listening. I'm DOTAN Horovits, and may the open source be with you.